And what you can see with this first question, so it's asking, is the discriminant of the function f positive, 0, or negative? And you can see that this is our third case where it does not cross through this x-axis. In fact, this is the case where there are no real number solutions. In this case, we'll end up with complex solutions. And just looking at our previous work here, so let me scroll back over, that's this scenario here where the discriminant was negative. So remember, when looking at the quadratic formula, so let me rewrite the quadratic formula really quickly. But this discriminant, the b squared minus 4ac, when this part under the square root is a negative number, then remember you're adding or subtracting square roots of negative numbers, which we define as imaginary numbers. You're not going to be able to graph those anywhere on this normal number line, which means that it's not going to go through this x-axis. So this is the case with, again, where b squared minus 4ac, our discriminant, is a negative number. So in this case, the answer would be negative. So let's keep going with these. So in this one, we want to actually calculate the value of the discriminant. So let me rewrite this function. So we have 4x squared plus 2x plus 6, and we're talking about the number of zeros that we have. So we know we're going to set this function equal to 0, and we can use the quadratic formula to solve it. And if we wanted to do that, we could. So it's the opposite of b plus or minus the square root of b squared, so that's 2 squared, minus 4 times a, which is 4, times c, which is our constant term, which is 6, and then everything is divided by twice a, so twice 4. So this is if we actually wanted to find the values of those zeros. But in this case, we're just wondering what the discriminant is. And remember, the discriminant is just the expression under the square root. So the b squared minus 4ac in this case, right, this is our a term, this is our b term, and this is our c term. So it was 2 squared minus 4 times 4 for a times 6 for c. 2 squared is 4, and this is 24 times 4, which is 96. And so 4 minus 96 would be negative 92. So our discriminant d, we can call it, is a negative value. And just like above, this is the case where with our graph, we don't know exactly what this looks like without further analysis, but it essentially is the scenario where the quadratic graph does not cross the x-axis. So the value of our discriminant, we can put that in the box. That was minus 92. And answering the second question, how many distinct real number zeros does the function have? Well, since it doesn't cross this x-axis, or in other words, since we end up with imaginary numbers here, because we'll have square roots of negative numbers, in this case, we'll be adding or subtracting those imaginary numbers, and we won't be able to come up with a value for our x-intercepts that we can actually plot on this x-axis, right? Because the x-axis is all normal real numbers. So the distinct real number zeros that we have would be 0. Because in this case, we don't have any real number zeros. We only have complex number zeros. So let's keep going with these. And looking at this case, so this is when the function just touches this x-axis here. So you might remember from above, this is when the discriminant was 0. But let's expand on that just a little bit. So again, I'm going to rewrite this quadratic equation since essentially everything is based off of this. And let's think about what's happening here. So if we only end up with one x-intercept, then this part that we add or subtract has to be 0. Because if this part was 0, so if b squared minus 4ac was 0, then we'd have minus b plus or minus the square root of 0 over 2a, which is minus b plus or minus 0. So we don't even need to do that because when you add 0 or subtract 0, it doesn't change anything. So we just end up with this one solution here, minus b over 2a. So depending on what b and a are, that would give us this value of 4. So in summary, anytime that the function just comes and touches the graph at one unique point, then your discriminant is 0. Because essentially this part that you're adding or subtracting is 0, and so you just end up with this one solution. So 0 would be our answer there. And let's keep going. So again, we need to calculate the value of the discriminant. So with these problems, you really don't need to write the quadratic formula down. It just kind of expands on what's going on. So the discriminant we know is just this b squared minus 4ac. And in this case, let's see, let me rewrite the function. So f of x is minus 4x squared plus 12x minus 9. And we're talking about the zeros, or the x-intercepts of the graph. So that's when the function is equal to 0. And we can determine our a, b, and c values. Remember, a is the coefficient on x squared, b is the coefficient on x, and c is the constant term. So when substituting these values in, we have b squared, so that's 12 squared, minus 4 times a, which is negative 4, times c, which is negative 9. And you might note, substitute my values in parentheses, which is especially useful for just organizing your negative numbers. So we actually have 3 negatives multiplied together. So the 2 negatives here are going to cancel each other and become positive. But then when 4 times 9 is 36, when you multiply this 36 times negative 4, the overall answer will go back to being negative. So 12 squared is 144. And we have 4 times 36, which is also 144. And again, one of those was negative, so we have subtraction here. And 144 minus 144 is just 0. So again, we come up with this case where the discriminant is 0. And remember from above that that's the case where, I didn't draw that perfectly, but where the quadratic graph comes down and just touches the x-axis at one point. Let me draw it maybe a little bit more accurately here. So it's just going to touch it only at that one point. And again, just as a reminder from above, when you use that quadratic formula, this discriminant being 0 essentially means that you're adding or subtracting 0, which adding or subtracting doesn't change the value, so you can essentially just ignore that part, and you just end up with this minus b over 2a. Or in other words, you just get one solution. So the value of our discriminant here, we just learned, was 0. And when the discriminant is 0, you have one distinct x-intercept. So in this case, to answer the second question, how many x-intercepts we have, that would just be 1.